Okay, I would like to welcome everybody, both here in the Wallenberg Hall and also all of you on Zoom. We are happy that so many people wanted to attend. We are around 60 people here in the hall and more than 100 on Zoom. So that's great. And the symposium of today is about sustainable diets and the protein shift. That is to say, to exchange animal sources of proteins to less climate burdensome sources. And my name is Ann-Sofie Sandberg, and I'm professor of food science at Chalmers University of Technology, and I'm also a fellow of IVA, Division of Biotechnology. And this symposium is organized by 3 Royal Academies here. And of course, the Royal Swedish Academy of Engineering Science, the Division of Biotechnology, and also the Royal Swedish Academy of Sciences, the National Committee for for Nutrition and Food Science, and the third one is the Royal Swedish Academy of Forestry and Agriculture. And the program committee is myself and Professor Robert Jan Brummer, who sits there, professor at Örebro University, and also Professor Maud Langton from Swedish Agricultural University, and Professor Maj-Lis Helenius, somewhere there, from Karolinska Institute, and of course Annika Åhnberg, who is also here from Division of Biotechnology at IVA. First, I will mention about the program. There is a change I have to tell you about, and that was unfortunately that Professor Peter van de Beer from Holland could not attend due to unforeseen personal reasons. But we were lucky to be able to invite instead Professor Edith Feskens from Wageningen University. So she will start the meeting with the same title as the former, The Healthy Diets from a Sustainable Food Systems, Turning Facts into Acts. And the next speaker is Professor Christel Cederberg from Chalmers, and she will talk about environmental sustainability of plant-based food protein production, and she will give an overview. And the next person speaking is Associate Professor Caroline Sorel from Örebro University, and she will give a political consumerist perspective on the protein shift. And political consumerism is, for example, that people, due to political reason, avoids to eat certain foods. But she will tell more about this. Then we will have a coffee break, and the next speaker is then from Finland, from VTT, and that is Professor Nesli Söser, who will tell us about food technology for development and production of novel plant-based food products. And the last speaker is Dr. Cecilia Meyer from Chalmers, and she will tell us about nutritional value and nutritional limitations with meat substitutes currently on the Swedish market. So I will start to say just a few words, and that is about the definition of what is a sustainable diet. And I go from the definition by United Nations and FAO, and there are a lot of criteria to fulfill to call it a sustainable diet. One criteria is that the diet should have low environmental impacts, and it should contribute to food and nutrition security, and to a healthy life for present and future generations. And sustainable diets are protective and respectful of biodiversity and of ecosystems. It is culturally acceptable, it is accessible, it's economically fair, and it is affordable, and it is nutritional adequate, and it's safe and healthy, while optimizing natural and human resources. But unfortunately, most common methods for evaluating sustainability today are only looking at greenhouse gas emission and land use, and it does not capture synergies or goal conflicts. And there are several examples of goal conflicts. For example, a conventional farming has a high yield per land area compared to ecological farming. But on the other hand, it uses pesticides and mineral fertilizers. And the ecological farming then results in more biodiversity of the soil and the field. So you see there is a conflict there. And if we look at the nutritional side, actually some sort of climate-friendly diets, a strict climate-friendly diet could actually consist of soft drinks, of pommes frites, of cookies and oils, but of course it has a very low nutritional value. So that is another conflict. And we also have to think about what is realistic. What is a realistic diet? Is it realistic that all of us becomes vegans and continue to be vegans all of our lives? So we have to think about those things. And I hope that we will be able today to discuss what is the path forward to a sustainable diet, that we can learn about transformation of food systems, what research strategies we need, and what are the policies agendas. So we hope for indeed a very fruitful discussion today. And by these words, I want to open this symposium, and I want to introduce to you Annika Åhnberg, who is, as I mentioned before, she is also from IVA Biotechnology Division, and she will take over as a moderator today. Please, Annika.
Thank you so much. Thank you so much, Ann-Sophie, and I, of course, will join Ann-Sophie in welcoming you all you here on site and all you participating on the web. And for those participating on the web, I also would like to add that you can put your questions using the chat function, and we'll try to pick them up here. There will be some possibilities after each presentation to put questions, if the speakers are on time, that is. Yes. As Ann-Sophie has just showed you, these are very complicated issues. What is a healthy diet? It can be different for young and old, for men and women. And it's not only a question about health for us humans, it's also a question about health for the planet. So what is a healthy diet for the planet? And we will try to look into many different aspects. And I'm very excited about this because I think this is such an important discussion and so often in society reduced to just a simple question, should we eat protein from animals or protein that are plant-based? And as you will see, it's much more complicated, but also much more exciting and interesting than this. So with this, I just want to introduce to you our first speaker, Edith Fesker. I can see her here but you can't see her? No?
I can hope you can see me and you can hear me.
So far, only I can see you, but soon.
Okay.
There you are.
Okay. Yes.
Welcome,
thank
Edith.
You. Yes, thank you. Thank you.
Edith Fesker is Professor of Global Nutrition and she's Chair of the Division of Human Nutrition and Health at Wageningen University in the Netherlands. And until recently, she was also the chair of the Scientific Advisory Board of the Joint Program Initiative Health Diet for a Healthy Life, which is a European on the European level. So please, Edith, we are so much looking forward to hearing your presentation. The floor is yours.
Thank you very much for your kind introduction. And I'm very honored to be here in your esteemed, establishment. I will present some slides of one of my collaborators, Professor Pieter van het Veer. As you already heard, he could not be here. I kept the same title, but I give a little bit my own input, of course, but also using basically his slides. So you see here my email address. I have to admit I have to leave quite soon after my talk. So I'm not sure if I can participate in discussions and the Q&A, but you can always send me an email for further information. I'm happy to discuss with you further. So my presentation will start a little bit from the basics again. And I think you all know, and that was your esteemed Professor Rockström who introduced them, the planetary boundaries. And we now know the climate change, the carbon dioxide, the nitrogen, the water use, the land use, and biodiversity are all limiting what we do in terms of agriculture and what eventually will be on our plate. Of course, I work in global nutrition, and we are not only thinking about what happens with agriculture and food. We are especially interested also in health, but also in, let's say, the demographics. And beyond climate change, we really fear that this will induce changes in the productions, changes in the yield, but also have a negative impact on migration, for example. And of course, we will all hear about the sea level rise. And of course, we in the Netherlands, well, we have tons of engineers who are now currently helping Bangladesh and Pakistan with their floods. Sea level rises we are used to them, I would say, or we try to keep water out as much as possible. But even we, with our engineering expertise, fear a little bit what is ahead of us. Now, for some of you, it may be a little bit, unclear sometimes what nutrition is. And I must say, I don't know so much about food. I know, of course, about food, but especially I know about the link between food and health and what happens in our body, what happens in our gastrointestinal system, but then also later in our circulation. So my own work was usually on obesity, still an important problem also in Europe, but also undernutrition, and also type 2 diabetes and cardiovascular disease. But of course, now we are not only concerned about the nutritional value and the health aspects, but also how the foods get at our plate. I don't need to remind you, but sometimes I do need to do that diet is really very essential in our global health, the global burden of disease. This is a paper from 2016, and you see here that dietary risks were on top, explaining a lot of the incidence of cardiovascular disease, but also diabetes and certain types of cancers, explaining up to 20% of the disability-adjusted life years. But also factors, which was number 3, high systolic blood pressure, is caused by overweight and high salt, for example. Alcohol misuse was on number 5. Child and maternal malnutrition was on number 6. So you can see all the red circles are focusing on environmental factors, which are basically risk factors, which are basically induced by unhealthy dietary habits. So my plea, indeed, also from a health point of view, we need to look at the constitution of our diet. Dear Chairman, you already introduced the sustainable diets, and I will, as you see, I will keep the same definition: low environmental impacts, contributing to food and nutrition security, and for a healthy life in present and future generations. Now, this indeed is a tricky problem, a wicked problem, because what we need to do is thinking about the trade-offs. On the left-hand side, our personal health, healthy life and well-being for me and my family and my grandchildren. On the other hand, the public health, the common good, so to speak, food and nutrition, security and equity for all people across the globe. And on the right-hand corner, the planetary health, low environment impacts for biodiversity and for future generations. And this is not always in agreement with each other. Sometimes it is, but in many cases it's not. And there is where the political issues are, in fact. And we as scientists, perhaps with modeling, can also help to elucidate these difficult discussions. We all know the linear model of the supply chain. On the left-hand side, the farmers, agriculture and fisheries. Because of agriculture, we think about the land use, the water use, the use of fuels, greenhouse gas emissions, the eutrophication and acidification. But of course, the food industry does a lot of good things in food processing and keeping them safe, but also, of course, at the expense of the use of energy, for example. Next, the retail. Very important for us as consumers, but also a source, for example, of food waste. And in the end, our food plate, which we like, and if we can afford it, but also give rise to, let's say, malnutrition, undernutrition, obesity, non-communicable diseases like cardiovascular diseases, cancer. We need to think about impacts of urbanization, about taste, price, access. I will come back to some of these factors later. Now, the linear model, of course, is not correct. I think you in the audience all realize we need now systems thinking. And systems thinking is a nice word, but in reality, not so easy to do, especially not easy to do really locally. But we have all kinds of feedback loops. So I focus most here on this part, what's on our plate and how this relates to health outcomes. But obviously, these outcomes in terms of health or dietary choices feed back into all these drivers of our food system. So we are a system with feedback loops, which makes it even more complicated to tackle it. Here are some slides from my colleague Pieter van het Veer. He had some data of 4 European countries, and he looked at the energy intake, which is on the x-axis, and at the greenhouse gas emissions calculated from these dietary data, representative for these 4 populations. You see here a positive association. The higher the energy intake, the higher the greenhouse gas emissions. In fact, in total, energy explained about 38% in absolute greenhouse gas emissions, irrespective of country and gender, taking them into account. But when you look at a certain, let's say, energy intake, 2000 kilocalories, a nice mean for a population, you see there's quite a large variation due to the food choices in greenhouse gas emissions. You see here the blue lines, I think Italy and some France, quite high. The yellow ones, the Czech Republic, especially the women, quite low. So for the same energy, there is quite some variation in greenhouse gas emissions. And actually, this is quite hopeful because this means that food choice matters. Overall, we think we need to mind the gap. So on one hand, reduce demand, global food demand, changing the dietary pattern, lower energy intake by less people, but also look at the production gap. Maybe we need to increase the production, and we know it's sometimes possible, for example, in sub-Saharan Africa, where there's still lack of irrigation, and with more irrigation and use of natural to blue water sources, there can be done much more. But also the diversification is an important issue. We now use the staple foods, about 10 crops provide 80% of our energy, globally speaking. And I think the diversification is very important, not only for health, but also for biodiversity. And of course, we need to think about the waste in food. This slide, I think you all know. This was from the famous Eat Lancet report. They did some great calculations based on these global boundaries and looked at nutritional adequate diets within those planetary boundaries. And then you also see on the right-hand side that, for example, meat, you see the cow there, our current intake is much higher than the health boundary would indicate. And also the wheat, the refined staple, the refined wheat products is much higher, while we are short on whole grain, on pulses and nuts, for example. So the idea, balance caloric intake, so equate energy input and output, take unsaturated rather than saturated fats, reduce added sugar, limit refined grains, and limit highly processed foods. This was then the advice in different types of food. Limit intake of red meat, starchy vegetables, for example. But in some areas, the situation is, of course, is much different. And that's where I work a lot. Southeast Asia, for example, the health boundary is not reached at all. And there's just an overshoot of starches and staple foods. While in sub-Saharan Africa, this overshoot of starches is even staggering, almost 800%, while a lot of limitations are here in the nutritionists, other foods. So the message we give in Europe is really not a good message to give in sub-Saharan Africa. And this is exemplified by my colleague, Namokolo Kovic, who said, as a response on this report, can this Eat Lancet diet as a reference diet for global population be helpful when so many in the world are not meeting their protein and micronutrient requirements, and so many children are stunted and waste and unhealthy and have limited growth capacity? I need to convince you that yes, animal products, of course, induce greenhouse gas emissions, especially ruminant meats, but also have their quality in terms of very valuable micronutrients and protein, for example. In meat also, the iron is important, avoiding anemia, zinc and vitamin B12. In dairy, we additionally have B vitamins and calcium. And also eggs and fish, of course, can be excluded when you're thinking about the vegan diet, but then you lack the long-chain omega-3 fatty acids. And in terms of eggs, well, they can be a very valuable source of the fat-soluble vitamins A, D, and E. So also here, trade-offs need to be made. What's further complicated things, and already the chairperson indicated this, that what is a healthy diet in terms of, well, the general population? So if we look at our protein requirements for a normal person, this is only 0.8 grams per kilogram per day. But for the elderly, you see as this active elderly person on the picture, we think we need more to be able to sustain this, the muscle health. But in terms of stress, in presence of wounds, for example, or to restore lost weight in cachexia, we even need higher protein requirements. So the protein is an important issue, and I'm glad you're going to discuss this later today. So in the model of Professor Pieter van het Veer, he called it the SHARP model. He said we need to balance multiple objectives. So on one hand, the healthy people, on the right-hand side, the sustainable environment, but also on the other side, it should be socioeconomic fair. It should be affordable, reliable, and also people should like the diet and the foods. This is a slide I borrowed from my colleagues from Animal and Plant Sciences, where we think, and you will discuss this further this afternoon, about replacing animal products and thinking about the protein transition. We need to reduce the consumption of animal products because of health reasons, and then especially processed meat, but also for sustainability reasons. We can replace, and we should replace, animal products then with alternative proteins, but also we need to redesign the today's food system. And that, of course, is the biggest and most difficult task. It is difficult because we can say we as consumers, we vote with our feet. So if we want something, I mean, the producers are going to produce it and the farmers are going to grow it. But of course, our eating habits do not occur in isolation. They are occurring in interaction with our social cultural system. And from our individual environment, it reaches to our community, the market, also our on country level and even globally. So the consumer behavior is embedded in many interconnected systems. So conscious, but especially also unconscious decisions are made at many different levels. And this means that there are very rapid decision cycles, sometimes like me going to the shop, but also very, very slow decision cycles. And you can imagine we in the Netherlands, we are struggling with nitrogen in the environment already for, 40 years. And even still our latest government is not able to solve this issue in reconciling the vision of the farmers and the vision of the environmentalist. A difficult issue. So what we do in nutrition, we prepare food-based dietary guidelines. And it's interesting to see that across Europe, there are many commonalities. So in general, we see fruit, vegetables, legumes, nuts, and seeds need to be eaten more, so they are positive. But the red and processed meat, the refined grain, the sweet beverages, the alcohol and saturated fat are the foods and nutrients to limit. Professor Pieter van het Veer had access to this quite interesting data. I already showed you a little bit. But he also looked at, for example, that this variation in greenhouse gas emissions we saw earlier also occurs here. In terms of land use, we see here on the left-hand side greenhouse gas emissions and on the right-hand side land use. So also there is this nice variation, and the Czech Republic also scores best in that dietary pattern in terms of land use, which is also correlated, I hope, with biodiversity, although I'm not sure. I think we need to know much more really on, let's say, indicators of biodiversity. A little bit more complicated slide also from him is that they tried to benchmark the different diets. And you see here the Eat Lancet diet as proposed. You see here on the x-axis, I hope you can see it. Here's the limit of 100% of greenhouse gas emissions. So the Eat Lancet diet, if you adhere to it, you reduce your greenhouse gas emissions to almost 60, so between 50 and 60% of the current use. So you change a lot. But if you look at the diet part, which is indicated here by a dietary score, 15 nutrients which are positive, -3 nutrients which are unhealthy, and look at the observed value, there are diets which are much more healthy. You see here a European-wide healthy diet based on the 4 countries I just showed you, while it's higher on the y-axis than the Eat Lancet diet. So there are healthy possibilities, but then of course you can already see the trade-off. This healthy diet is only reducing the greenhouse gas emissions with 10%. And the P stands for preferred, because that is also something which is very interesting. And we found out, and it is more recent work, how about the taste? If you look at the left hand, you see the most healthy and sustainable diet has a quite neutral taste. 43% of this diet has, according to our in-house developed taste database, a neutral taste. While on the least healthy and sustainable diet, it's much more savory, for example. Not so much sweet or fat, but more bitter and more savory and less neutral. In a sense, what we as consumers will say, much more tasty. And of course, this is difficult because what do you choose in the supermarket? We can think about system thinking, but in the end, it's on the individual level, the choices are being made, although nudged in one way or another. So we will make this task much more easy if the environment works with us and not pulls up a heavy slope to make us individual diet behavior change much more difficult. But what can we do? So if we think about determinants of food choice, the scientists will indicate, yes, it's biological, hunger, appetite, and especially taste. I put that in red. There are economic determinants, cost, income, availability, so the price is very important. Physical determinants such as access, education, skills, but I think especially time, convenience is now a very important decisive factors for consumers to choose a particular food or not. And in addition, the social determinants, the psychological determinants, and the attitudes, beliefs, and knowledge about food. And note that health is nowhere in this list, and this is from the behavioral sciences people. So how healthy a food is, well, that maybe is something about the knowledge, but not more than that. The Dutch Nutrition Center has come up with some basic principles on sustainable diets. And this is a nice way, I think, to interact with the consumer, where at least one pieces of the puzzle is there. To reduce the amount of eaten, let's say reduce your food waste. So they advise the shopping list, store foods properly and don't buy too much. Don't eat too much. Well, that's all clear, especially in terms of obesity. Eat less red meat and processed meat to shift foods with a lower footprint. Also choose the right fish, of course, with the right logo. Use less processed meat and cheese on bread. Well, this is typically Dutch, our food pattern. We eat a lot of cheese and bread on our favorite lunch and breakfast sandwiches. There they give practical advice on how to replace it, so they really start acting. Increase plant food intake, the existing ones, whole grains, fruits, vegetables, potatoes, legumes, nuts, and oils. They don't mention the alternatives yet, and that's interesting. I hope to hear more from you. And account from food source and season. So choose foods with low footprints, seasonality, no air transport, etc. And also here, I think there is something to discuss, because how does a consumer know? Are there sufficient well validated logos? And how does this change? Also with changes now in the food production, because food producers are aware, and also sometimes in changes in food farming systems, because everybody is now aware about the environmental impact and try to mitigate this. So this needs updating, continuous work. So if I think our future is on our plate, but the eat less advice still questions and asks for additional information and research. Is it for all? Do we need to think about the vulnerable groups such as elderly? How does physical activity play a role? We need to increase plant foods and shift away from ruminant meat to pork, chicken, fish, but how about the important micronutrients? And of course, don't go to the fully plant-based diet with French fries and Coca-Cola, as the chairperson indicated. Sustainability is not about quantity, but especially also about quality. And we need to think about the foods which are affordable, especially to the groups with lower socioeconomic class, which in our societies have the really unhealthy dietary patterns and the highest disease rates. And of course, we need to look at the total diet and don't forget the consumer. So in the end, you saw this slide again. I think there are, based on this slide, this simple slide, already action perspectives to be defined at various different levels of governments. The food production system, the income, fat, sugar taxes, heavily debated in the Netherlands, but that's also political. Fair trade, animal well-being, a very important reason for the consumer to stop eating meat. Food reformulation, I think we can do there a lot. Although then we have an issue that some may argue that ultra-processed foods are not healthy, and this is also a debate in our field. We need to think about the right portion sizes to limit them. Of course, we need to think about food packaging and to make them more environmentally friendly, and we need to think about the whole supply chain. On the right-hand side, you see a slide I just made today, because this was based on a very recent report launched last week by our university on nature positive futures, food systems for a catalyzer for change, in which all the groups of our university, so not only food and diet, but also the social sciences, the farming, the economy, and the general communities took place and made discussions about how we can start transforming this whole system. And this is, I think, something difficult, but also highly needed. So we argued transdisciplinary research is needed, including the consumers and the citizens, and we should especially not forget the implementation science, because what we know now, I think we already implement this, because otherwise it's going to be a little bit late in terms of climate change. Thank you very much for your attention.
Thank you. Thank you, Edith, so much for this excellent introduction to the subject of today. Now let's see, we have some minutes for short questions. Do we have any question via the chat?
No, not on the chat, but I have a question myself.
Okay.
Okay. Please use the mic. Or you can step up here. No? Yes.
Thank you very much for an excellent introduction to this subject. But I was wondering, what do you think are the main obstacles to this transformation? You showed that in Holland you have suggestion for diet transformation, and you have nice scenarios for the future, but what are the main obstacles?
Yeah, that is a very good point. We have just been discussing this. I think there are multiple. I think the first of the thing is communication. That's what we feel also is now happening in our polarized world on the nitrogen discussion between farmers and government. People are staying into the silos and not understanding each other's, let's say, incentives and each other's, importance or need or agenda, so to speak. So I would start, our experience in small communities, for example, here in Wageningen, where we have a community garden, start small, is that people need to start to talk to each other and also try to understand each other's language and to be respectful of that. So that is very small. And this is small, but it is also on the larger scale in the politics. I think the civil servants in the ministries of agriculture and the Ministry of Public Health, they all understand. But in the end, in our state at least, it's a matter of politics. To what extent do we make the choice to put more money, value for money in the health and the environment versus to the economic affairs and the profitability of companies and farmers? So this is, of course, outside the area of my expertise, but we have political science to help us with that. And so that is one thing. And the other thing, I think we need incentives, even more incentives for technical innovations. We are sure they are there, and you know them even better than I do, but also in our university. But how to scale them up and how to have the people, that is our main issue as well for the consumer, that the consumer pays the true price for what a product really costs. It's heavily subsidized, some products. And of course, the environmental impact is never calculated in the price. If we do, some foods would, of course, be much more expensive. But then what happens with the affordability? What happens with the low-income groups and their diet and their food security? So this is also a tricky trade-off. But if we don't start somewhere, everybody starts looking at each other. So someone or some parties need to be bold enough to make this change. And especially in terms of consumers and companies, I know we are looking at Europe also, because, if we are starting making the sugar beverage taxes and Germany and Belgium across the border don't do it, everybody goes there for the shopping. So, I mean, we need to do this together. Is this a helpful answer? Maybe I missed the boat concerning your question, but yeah.
It is a helpful answer, though there is not an easy solution to the things that we are discussing now, because they are very complex and we need to do many things at the same time. But once again, thank you so much. Is there another additional question?
There is one question from the audience now.
Not from you?
Well, it could have been from me, because I think it was a very necessary question. It's from Ingrid Underland, and she's asking, I wonder how come meat and fish are put together in one food group, given the very low carbon footprint of fish compared to red meat. Some species having a low footprint, footprint as beans. Generally, a comment on the shift towards more seafood would be interesting.
Yeah, I totally agree. I understand where that comes from. You're from Scandinavia, you eat much more fish than we do. But a joke aside, I think in the Eat Lancet report, because that's based on that, I think this also dates from 2019. And I know many people are now working on a newer one, version 2.0, where all these concerns will be taken into account. And this is especially a sensitive one. If I look at the protein recommendations from the Eat Lancet, I think for all animal foods, there was a recommended range, which was 0, the lower value. And I think if you look at all the protein foods and eat 0 from anything, so irrespective of it's processed meat or fish or eggs, I think this can never be a healthy diet. You need to have a really, really additional, lots of vitamin supplements, etc. So I completely agree that this group was really, not well thought of, and further work needs to be done on that. And they are working on that, I know.
Thank you, and thank you so much, Edith. We would have wanted to discuss with you for a long time, but I know you haven't got the time, and we also need to move on here with the seminar.
Of course, yes.
So I would like to welcome...
Thank you very much.
Thank you. Shouldn't we give her an applause? So I would like to welcome Christel Cederberg, our next speaker. Christel is professor at Chalmers University of Technology in Gothenburg here in Sweden, and does research on sustainable biomass and agriculture production. And she has a long experience, which I know because we have met many times through the years, of doing life cycle analysis. And you are especially interested in method developments of environmental analysis. And at present, she is focused on measures and techniques for enhancing carbon sinks in agricultural land and in landscapes.
Yep.
Please, Christel, the floor is yours.
Yeah. Hello, everyone, and I go straight ahead. This is my agenda for these 20 minutes. I will first just have a very short on which environmental aspects are important to consider when we talk about sustainable food. And what do we know about these aspects today? I will just give you a short information about some late reviews, and then I want to finish with just, there are, as others former speakers said, we can really do improvements, and a lot of innovation is important and much is happening. So, planetary boundary came in 2009, and this concept of looking at the planet and these Earth systems, important Earth system process that we should not stay within a very safe green space, has become very much used. And I think it's a very good foundation to talk about when we talk about what are important. And for example, if we look at climate and the disturbance of the nitrogen and phosphorus cycle, which are two of those processes, very important for food. They are supposed to be transgressed already. And we also have other important for food production. There's the freshwater land use and biodiversity losses. And this was in 2009, and I thought I had to do some reading up. And for example, in the very earliest, when it came, there was this called chemical pollution. And chemical pollution is now called novel entities. And in 2022, that was this group at the Stockholm Resilience Organization, also with some Danish researchers that have worked a lot with toxicity and LCA. They did this really nice paper, and they suggested a threshold for novel entities, which was based that we are today increasing and using so much chemicals, so we can't even track and assess and monitor them. So they had a very different way of looking at this. And there you can see, do I have a pointer here? Yes, yeah. You can see pesticides. They started with the production of pesticides. They would come in 2008. Before that, they couldn't even get data. And then it's normalized to 1. And you can see only in these 15 years, it has increased a lot. You can also see antibiotics, for example, an important chemical. I will go further on here. So that is a pesticide bit, but I will come back to land. In the early first edition, land use and land system changes were included. And so far, there is only a threshold talking about the quantity, how much land are we taking from nature. However, I would like to highlight these two because there are a lot of discussion about land quality and how do we use land and land degradation. And as I see it, we do not today at all have enough indicators to indicate if food production is having degraded things like soil erosion, compaction, etc. And it's even so important, so we have one of the missions that European Union have launched is actually for healthy soil. So in my world, we have to get better indicators of this. And here is an example, which is research which we have done. England is one of our PhD postdocs. And here we have looked at how does it look in Europe, and we have looked at a lot of data from different, and we have looked in small regions. And here we have singled out where do we have big soil carbon losses. And you can see the redder the higher, and that is in relation to the normal condition. And here is the abundance of how much dominating annual crops are. And it's very, very clear that this cropping of annual crops is tough for the soil organic carbon losses. And this is very much, I would say, almost not at all included in life cycle assessment and carbon footprint so far. And I was asked to say something about these alternative plant-based vegetables. And I think that very many of these annual crops are actually within these groups. And of course, biodiversity, which has come up more and more. And I can just, if you have not seen this very good assessment of EPBS, which are doing this. So what do we know about this today when it comes to food system? And we are having a work now together with colleagues at SLU. And we are doing a paper here, and I have just present one of the results, preliminary results. And we have asked ourselves, when we find in the scientific literature, how are diets, what environmental aspects are covered when they are looking at the environmental sustainability of diets? And here we have the number of studies. We have looked at in total 78 studies. And there you have these different ecosystem, these very important processes that we want to have safeguard for the planet. And then we have called the indicators that are giving us information about the environmental sustainability. We have used this driver pressure state impact response. And in general, this is a system of characterizing indicator. And for example, a driver is the demand for food. Pressure, for example, fertilizer, that is the use of fertilizer. And the impact, that is if the fertilizer is leached out and going and making eutrophication, then we are going to say something about this pathway from driver pressure to an impact. So this is a much more sophisticated and informative indicator. And what this shows is that climate change, calculating carbon footprints, is much more done. And it's much more sophisticated indicators. While, for example, land system change and water use, much fewer. And you can also see the blue ones. And many of these are actually just informing, I use so much land use to produce that product. And that is not enough. We don't know if it's degraded or not. We just know how much it is. And you can see here, for example, novel entities, chemicals. It's very, very little. So it's this carbon footprinting that has been very big the last 10, 15 years. And I think it's because climate change has come so much up on the agenda, but it's also because it has been very easy to get money to research in this area. That is the clear thing. And here we have this, where we have beef meat, and we have lamb, we get pig meat down here, and here we have the vegetables, protein alternatives, for example, peas and tofu. And you can see this is a big review from Switzerland, done some years ago, very, very ambitious. But this is, I would say, we know quite well now after 15 years of a lot of these type of studies. Line Gordon and her team had this very nice paper. I have the reference there. It's free access, and it was actually published in Nature Food last week. I had to update myself a bit to come and talk. But here they have looked at what they call new food system technologies. So, because so much is happening now in what we do food system. And they were looking at the plant-based alternatives, which you can see from very many studies the last 2-3 years have come. And vertical farming, blockchain technology, and food delivery. And here they have looked at a number of studies, and you can see sustainable indicators here, and also economic and social. And again, if we have these plant-based alternatives that we now can buy so much in the shops, you can see that climate change, even eutrophication, some land use, quite many studies. But for example, biodiversity, very, very few. And what they say here, they say we observed high-level agreement across the literature that plant-based alternatives tend to have a lower environmental impact than conventional animal-based products. But again, and I discuss also in the paper, we don't know so much about biodiversity, for example, or what else here? Fossil fuel depletion, which is strange, I think. This is a very new study that you can look at. I have been doing some pesticides work, and as I said before, chemicals and novel entities, we are using more and more in the global food system. And one of the very big problems is that we need to have a lot of data. And especially when we talk about developing countries, these data are not there. They are not there in the use, but also the effects. I mean, how do the chemicals transport to water and effects on human being? We did a paper a few years ago. It was Rice and one of our PhD students at Chalmers, where we did a very, very thorough pesticide inventory and looked at using life cycle assessment, the most advanced method to do assessment, impact assessment of freshwater toxicity, potential freshwater toxicity due to pesticide use and losses. And we look at pork, chicken fillet, beef, milk, bread, and pea soup. And here we did like this, that we had very good data, and we did these food products, and all of them were produced in Västra Götaland, so we used very good data on pesticide use. And then we also had soybean or soy meal, and I have been there studying it, so I can say, because I've looked a lot at it, so I think we had as good data as you can get from using soy meal. And then we did this analysis using something calculated that comparative toxic unit for freshwater toxicity. It's a bit complicated, my limited time, but it is like a carbon dioxide equivalent, but it is a pesticide equivalent for toxicity, so take it as that. And we had different functional units. We used megacalorie per food, of protein, and then we have different type of other proteins. So just to check out that if we change the functional unit, that is the reference basis, that we would still have the same ranking or scoring between the products. And here we have normalized the results. So we put the chicken fillet to 1. So what this is actually tells us is that beef milk comes out much better than pork and chicken, and best comes the bread and wheat here. And there is one big reason for this, and that is that the soybean is so heavily used pesticides and very toxic pesticides, so they fall out very much. And we have in chicken and pork, we have soy meal. And this could be interesting because we can also see the pea soup, that was peas grown up in Västra Götaland region with relatively small amounts of pesticide. We can also see that it can be very low. However, these type of studies are very unique because it's very seldom included. How am I in time? 5 minutes? Okay, I talked until you... Yeah, fine. I said... Annika just said that I talk about land and landscape, and I think that what I want to say before I round this off is that in the methods, when we calculate and do this assessment of diets, we look at per kilo of food, and then we put together a diet. However, it's more and more obvious now that there are many values, like high biodiversity, ecosystem service, that we can't just look at the field level and the product level. We'll have to look at the structure of the landscape. And we use this, it's pictures from France. I had it with some French colleagues, we were discussing this. And it's very clear that all the other the same. If we have a mosaic landscape like this, to this, which would be very efficient, probably have very little square meter per functional unit, which would be very good in all this as we calculate. But this type of landscape can sustain about 20-25% more biodiversity just because of its structure. And these type of extremely important things are not including at all today in analysis. I just have to say that. So, I will finish up now. I have kind of changed my career a bit. I have been calculating a lot of LCA earlier and sitting and putting together. And I got a bit actually tired of it. I have to confess that. And I think it's very important now that we find how can we change and improve agricultural production. Because just as Edith said, there are lots of innovation happening out there. And it's very important to understand that it's not status quo what we have. So just a few examples. This is our herbicides, spraying. We have herbicides. And we now have, for the last 10 years, have this type of machinery that has been developed that can actually have extremely good cereal and also in rapeseed with no at all. And it's organic agriculture that has been driving this, but this is also used in conventional. And this is extremely interesting to have automatic robot or any type of automation. And this is goes in sugar beet and another row sow, and it both can see and put a sow and plant, and it can then take away the weeding, so you don't have to spray. And very interesting, it weighs 700 kilo, which is very good for not compacting soils, because traditional agriculture has gone towards heavier and heavier machinery, and this little machinery can go around and work in the field. Again, I think that I'm a bit worried now. You can hear now that organic agriculture is going back, and it's sometimes criticized, it takes so much area. But it has been very, very important to be a driver to get this type of solutions, to get away from pesticides, because we have to get down pesticide use in food production generally. Then I will just finish off with a very, what we work today with quite a lot together with Danish colleagues, and it's to have green biorefinery. And now we are changing paradigm. We are not having an annual crop anymore. We have a grass clover crop, which we have good knowledge of due to all the livestock. We bring that into a green biorefinery, and we can extract the protein. And for the first part here, we have extracted protein and give that to monogastric animals instead of soy. And this press cake can be used by animals. But there are potentials here. So how about to make human food out of this? It has already been tried in Denmark. And we are talking about using these fibers because we have to replace plastic and have this all integrated with biogas to have this type of holistic way. It's a completely change, and the very big positive here is that this grass club don't need any pesticides, and they store carbon in the soils. A lot of happening. Denmark is leading the development in this, and it basically is that there are a lot of potentials to actually refine different type of products and energy and materials from this extremely environmentally kindly biomass. And we have had this project, Green Valley, and I just show you how it looks in practice. You take in the grass, and up there is a screw press, so you have a mechanic fraction, and you get out the fiber-rich press cake, which looks like that. Cows can eat it, or it can go for biogas, or it can be material. And here we have this interesting protein concentrate. And now I was in Denmark in May, and I visited Biorefine on Western Jylland, where they now have an actually small business of this. And they have improved this protein quality, so they have a 48% high protein level, so they can just take away soy meal from pigs and give them this instead. And that will actually change the climate footprint of pig, because then we don't need the soya, we have a carbon sink that bind up, and we would lose a lot of protein. So I think this is very important that we don't stick how have we produced agriculture before. We have to think about these innovations and how they can come. So my thinking here, ending up, I would say that today that there are very important environmental concerns that are under-assessed. Land quality, biodiversity, land degradation are the most important, and pesticides, the effects of pesticides. And why are they? Well, I think actually it has been so much easier to get research money for climate because it has been so in a topic. But there is also this concern because many of these, they require a lot of data at local scale. And sometimes in the LCA family, I can take this as an example. If we want to do something, soil erosion, and I put together a food and I have ingredients from 8 different countries, and I want to make a number for soil erosion, then I have an impact indicator, which is per country. And then I have to assume that that is an average. But in practice, soil erosion is very, very at a fine scale. You must almost look at the farm level. And that is our, how should I say, our global trade today is so anonymous. And you have this big flows. And I mean, retailers, they don't have much ideas of what they sell on all their stores, actually. And I think Edith said it, and I think this is really important. We have this food and feed database with environmental prestanda, and they are just used and used, but they have to be updated, both with what's happening now that you are using new technologies, and also with these under-assessed environmental concerns. Otherwise, we can't say enough about sustainable diets. Okay, and landscape, that's the thing. This is from my home. So, thank you.
Thank you so much, Crystal. Really, really very exciting, and so important that we think about what can be developed in the future and just not look back to yesterday.
Yeah.
And also really what you say about all these areas being under-assessed, that I think is extremely important, that we get better data and facts.
Mm-hmm.
Do we have any question in the chat?
There is a question.
Yes, please. Use the microphone. You have a microphone somewhere there. Can you please?
Where? On the side of the chair.
On the side of the chair. And press the button all the time, I think.
Yes. Okay, you hear me?
Yes.
Yeah. I'm thinking about the industrial trawling of the Baltic Sea and the resulting of losses of all fish.
Yeah.
And is there any possibility to make a substitution of that, making something to grow which will give protein enough for the salmon?
Yeah, actually, if our research application is fruitful, we hope to get a new project here, Green Valley, where we actually it's the Danish researchers. They have this test pilot, and we now have ideas how we could get this what we call green protein to come up to a protein content of 70%. And we will try it on fish.
Okay.
Yeah.
70% is from soya.
No, 70%. That
I don't like soya.
no. So that is the thing. I think for the salmon to be the salmon's farming, you need to replace both this captured fish, which is trawled out in the but also the soy. So I mean, you have to have a total shift on here. So this is very interesting. But as for now on, it can replace for pigs and for layer hens. It's just to change the soy into this green meal, and you have the same output.
So the salmons could be vegetarians?
Yes. But they are, I have learned now when we have written the application that they are extremely tasty. They are worse than people. If it's not good, I don't eat it. So.
Thank you so much. Do we have another question? No? I see no one wanting to put a question. So once again, thank you so much, Kristen.
Yeah, thank you.
And now I would like to welcome our next speaker, Caroline Sorel. Please come here. We have already touched upon the fact that what we eat, our diet, it's not only about facts and then we can eat what is supposed to be good. It's also about the context we live in, the culture we live in, the habits we have, the political ideas we have, and so many other things outside the eating itself. And I think that Caroline will bring more of these issues up to us now. Caroline is a senior lecturer in political science at Örebro University here in Sweden, with a main research interest in the role of social influence for behavior change, and at present with a focus on how, or even if, social influences have an impact on our change of food habits. Please, Caroline, the floor is yours.
Thank you. Good afternoon. I feel very honored to be invited as a speaker here and to contribute some other insights. So we have heard already a little bit that there are many technical ways of how we can assess what a sustainable diet is. We can look at the environmental impacts of ingredients, at the transportation, at land use, water use, etc. And they are all also from a political perspective something important, important, but I will more talk about the consumer perspective today, since from the consumer perspective, from the consumer who is politically interested and also aware, or the other way around, aware and also interested, there is more to the sustainable diet than only the environmental or biophysical impacts. Yes. So I wanted to start this talk with a picture of something that might be quite familiar to most of you if you are Swedish, maybe also to non-Swedes, and maybe you are also already looking forward to it because it's quite soon, the Swedish Yule Board. And I picked this picture because I think, or I just recently again experienced that it's an example par excellence of the fact that the protein shift is still a long road ahead, and also it will be a quite difficult battle, or it is already a difficult battle to fight. So 1 year ago, I was planning my first Yule board in Sweden, and I was a little bit naive, probably. So it was for 30 people, and I just mentioned to the caterer that we are going to be about 30 people with some vegetarians. And it turned out that at the end, we got delivered only non-vegetarian food, except for bread, green kale salad, and boiled potatoes. So it was, even for the meat eaters, a very heavy diet, or a heavy dinner. And I checked with the caterer, and there seemed to also have been some problems in taking up the order. But overall, what became very clear was that so this restaurant, the caterer, was already selected by us, knowing that they are very good at providing ecological food, and usually also a very good variety of vegetarian options. But still, when catering for the Yule board, they were just focusing on meat, sausages, and fish. So my impression was that they had the idea that they have to conform to the norms or the tradition, and deviate from their normal practices of having also some vegetarian options, and just focus on what they thought that people expect to be finding on a Yule board. And earlier this week, when finalizing this talk, I was finding myself again in the situation that I have to organize a Yule board for this year, and I ordered then one explicitly stating that we are going to be vegetarians, and I got as response this menu, which is again that an offer where the vegetarians would get bread and butter, a bit of cheese with jam, and maybe also they can find some beetroot salad. Vegans would be completely undernourished with this menu. So this time I learned from this experience and contacted a caterer and made a clear suggestion for some more balanced menu, which now is more 50-50. I still hope that we don't have too many vegans signing up for the Yule board, but it was possible, but it was quite of a battle. And so when thinking about this also, the origin, or what I want to illustrate with this example rather, is the point that I see in it, that we have all these traditions and habits in ourselves that influence what we want, what we expect, and what we look forward to also. And it's very difficult to change these habits from multiple perspectives. You find a lot of resistance and influenced by certain values and norms and needs and interests of the single people. And so it's about food has become some political issue because there are so many values and habits, things that we cherish involved, like the idea that we have meat and sausages, fish on our Christmas plates. It has its origin also in the fact that for a long time these were things that we did not have access to so often. So it is now still associated in our minds with the idea that it stands for prosperity, for comfort, and also for special occasions. But once we think about it a little bit more, we can probably recognize that the extraordinariness of the occasion of eating meat or sausages or fish is not that, it's quite fictional nowadays. We can eat it almost every day, like herring or sausages, and it needs also some kind of reprogramming in our collective and also individual minds, and this can be quite uncomfortable or also scary, because it also implies that we have to challenge our thought patterns and also things that we, as mentioned, also cherish. And it implies that we have to change how we live. And as said, that then implies a lot of, it makes people scared, uncomfortable, and people deal in different ways with this. Some simply ignore it. Some deny the need that we have to change our food patterns. Some they accept it, and some actually embrace it. And that is then also where the political consumer comes in. So I'm not sure how many people are aware or familiar here in this room with the concept of political consumerism. So political consumerism involves many different things. Among other things, different kinds of activities. So a political consumer can be a person who boycotts to buy certain products for certain political reasons, which can be the animal ethics, human rights, environmental issues, and then in reverse, there are also the so-called boycotters or boycotting, which is the most common type of engagement of political consumers, which involves people buying explicitly certain products or from certain producers because they think that in this way they can support or express a political standpoint, like that they support ecological farming, for example, or a vegan lifestyle, or also certain practices of producers. And then next to boycotting and boycotting, there is also another form of political consumerism, which is more the communicative engagement of political consumers. For example, on social media, engaging in public shaming or also corporate shaming or corporate praising campaigns, with the ambition to make other people also aware of that there is something like politics which is affecting that there is a politics surrounding production and consumption of products. And finally, there is also some consumers who not only once in a while let their shopping choices or food consumption choices be steered by political considerations, but there are also people who fundamentally alter their entire lifestyles. So they engage in a lifestyle change and, for example, adopt a completely vegetarian or vegan lifestyle. And all these different kinds of activities are also tied to they can relate to ecological eating or like animal-free eating, but also to fair trade, to the corporate social responsibility practices of companies and so forth. So political consumerism is very broad overall. And it is also, it comes with the question, how relevant is actually political consumerism? And the statistics, so this is a survey that was conducted in Sweden, a general population survey. This data is now from 2019, but I also looked in my data from 2021, and it's the same figures, so there's no big change. And so what one can say is that about half of the population in Sweden, and actually also in in many other Western countries, are quite regularly engaging with the politics of consumption, like letting political considerations also affect what they buy or not buy. So also statistically speaking, here in the room should be quite many or several political consumers. Yeah, and the relevance of political consumerism is quite big in especially the European and North American and Australian context. However, it is also clearly expanding in many other countries, sometimes for slightly different reasons. So in Europe, or like in Western countries, it's very often about human rights, animal rights, and the environment, while in non-Western countries, it's often indirectly kind of associated to the environment, but more directly also associated with food security, bearing in mind or considering that very often people there are exposed to very high levels of pesticide use, which then are affecting their own health, the health of the children, and so forth. And also to environmental degradation. People there are quite often exposed and are getting more and more aware that also by altering their own consumption choices, they can somehow affect the ways in which they themselves are also living or producing food. But there's even more. So political consumers, I am conducting currently also interviews, and many political consumers are actually looking also for all the transparency that has been also discussed in the previous discussions about how much, what is the environmental impact actually of a certain purchase, of a certain food choice, a dish. So that is very important, but political consumerism it can also be affected by other considerations than only the technical facts. So it's the traditions and cultures, like in the Yule board, for example, or certain food traditions that we have on special occasions, certain values and norms that are also inside of us, maybe through socialization when we grew up, or in the social circles in which we live, that we might have certain green or ecological values which can then affect the food choices. But it can also be conservative values or values of patriotism or nationalism also. This is actually an element which has also been on the rise over the last years, like the idea that buying from the own country is something one should do because it's better. And this better can mean many different things. It can mean that for some, the transportation is shorter and therefore also the environmental impact is lower. But it can also mean that some people just believe that the products are produced in a more trustable way. So my favorite example here is, for example, when back in 2016, I was traveling with the Trans-Siberian train, and I was stopping for a few nights in an elderly woman in Irkutsk in Russia, and I was living with an elderly woman, and we were having in her kitchen some self-baken bread and tomatoes, and she just told me that she would never eat Chinese tomatoes because they are full of pesticides. She only trusts the Russian tomatoes. And I didn't tell her in that moment, but I was thinking I would never trust Russian tomatoes. I would probably just trust the European or, from a European neighborhood, the tomatoes. And I am also perfectly aware that this can also be completely wrong and a fallacy. So but still, this is a very important consideration for many people. So what is close and dear to us, we trust more, and also this is a form of, kind of political consumer motivation for many. Well, and then who are political consumers? actually people like this elderly woman in Russia and me, so mainly females in either the 30s or then when they are elder. It's mainly people with higher education degrees who are more affluent, and since also having less material problems, they often tend to be able to afford basically to have post-material values, which are so-called post-material values are like valuing equality and freedom of expression, and not so much having to care about having enough food, for example, on a plate, or like certain material coverage. And it's mainly people who are also tend towards the political, ideological left, or then also who tend to be affiliated or feel closer to green parties and left parties. However, there are also two big buts in that. So on the one hand, looking then at the environmental impact, something that I would want to highlight also, and which has been discussed also more and more in the social sciences, is the fact that people who are affluent might be more likely to be political consumers, but their environmental impact might actually be higher than of those who don't have so much money, simply because of owning, for example, larger houses or larger cars, or if some might not even own a car if they don't have enough money. And so here also, what my point with this is that also when judging about the engagements of individuals in political consumerism and drawing conclusions, we have to bear this in mind, that there are different capabilities also, and we should not think that just because some people can afford being political consumers, they are better people. And the second but is also that I have been talking about the patriotic, nationalistic motivations also for some people in engaging with political consumer decisions. And here the distinction between left and right is not that neat to draw. So here we find also political consumers on both ideological spectra. And then another kind of interesting question is also, why are certain people not political consumers, or why are some people political consumers only at certain times but not at others? And some of these things have already also been mentioned before in the previous presentations. But I'm picking it up again also because it's very important in all the discussion of political consumerism to think about there again the cultures and traditions which can people prevent from, for example, buying plant-based food for certain occasions, or also in general for their everyday diets. It might be because certain biological needs, like iron, for example, cannot be fully covered by leaving certain foods, for example, out of the diet, even if from an environmental perspective that would be the more suitable decision or the more recommendable decision. Then there are, of course, habits and also tastes. So also we have over many decades or centuries developed certain recipes which have also, they have become so internalized by many of us that it's easy and practicable to do it in our busy everyday lives. They have also formed our tastes. And now having to switch our diets, this can be quite challenging, or also just sometimes not really feasible in terms of time and other considerations. And so that can also be a barrier. And then the accessibility is a big issue. Time and again visible that when we go to the supermarkets, it's very difficult to identify and often also to obtain actually truly sustainable alternatives when it comes to food and also with many other products. And also we are not living in an environment, which is another factor, in an environment which actually encourages to live sustainable lives, both when it comes to food and in general. So these are then also hinderers. And finally, there's also a lack of knowledge on many levels. Even probably many people here who might have a lot of knowledge about environmental impacts of food, it can be quite difficult then at the end of the day to know what is actually the best food choice in this very moment. And yeah, so this is something which is also preventing many people from engaging with another kind of consumer choices in general. And yeah, so what we need is probably a more practicable and feasible and realities that make it more practicable and feasible to take the right decisions and also to actually make it easy for people and tasty to shift towards more plant-based, protein-rich diets. And I think we will also hear more about this later today, or in general also discuss it. And yeah, then also something that we need to bear in mind, what is also shown in my research quite often is, well, because I'm also doing research on it, but what we can see is that the role also of the social environments, of communicating with the people around us, getting inspired, getting motivated to experiment a little bit with new kinds of foods. Here, the social environment, both on social media but also in our offline lives, can play a major role. And I think I should get finished. So yeah, I just wanted to maybe wrap up with a short outlook that so yeah, in political consumerism, in political science, we define political consumerism as a form of political participation, and in many respects, this has been for long also been identified as a choice of the consumer, of the individual, to take all the responsibility on their own shoulders, to put pressure for a shift towards new consumption patterns, new dietary patterns. And to some extent, certainly that is also true. But overall, what we also see more and more is that there is also on top of that, or in essence, actually an expectation for political action. And so, because I was asked also to reflect a little bit on, at the end of the presentation, on the future of political consumerism, also in relation to the protein shift, I think here what is needed is, of course, a very active consumer base of consumers who in their everyday lives also continuously and actively reflect upon their own choices and inspire each other, but also we need a more favorable political environment in which there's more broader political consensus and also an active acknowledgement of that we need a protein shift and that it's also possible, and yeah, political actions. And so I just, yeah, wanted to, I wanted to close also with this encouragement to thinking back on the Yule board, to maybe also start ourselves this year with making the Yule board a little bit or fully animal free, except for maybe pets of your friends and guests. Yeah, but I think that's hopefully a good overview. Thanks.
Thank you, Caroline. So very interesting. You know, I got a question in my mind while I was listening to you, and that is, knowing that we need to change our eating habits, and we need to eat, at least in this part of the world, we need to eat less, and we need to eat less of some products. Would you say that political consumerism, is it a driver for this change, or is it an obstacle? I can see that there are many conflicts created around eating and eating habits, and what do you think?
I have been thinking about this a lot, and I also have sometimes the thought that probably the politicization of food is a big problem indeed, because there are so many interests and like a lot of values coming in, which very often are not really rational and reflected, and which prevent us very much from taking on the change that is actually needed. But on the other hand, political consumerism, like these activities, also have certainly contributed to the fact that we have it on a public agenda, because political consumerism has been there for 30, 40 years or so, and I would say that it was definitely one of the, it has contributed to a broader awareness also, both among politicians and individuals, that there is such thing as the need for a protein shift, because we can, as researchers, discuss it very much in our bubbles, but it needs a broader, I think political consumerism has helped here to get broader traction.
Thank you. Do we have a question for Caroline? Do you have any question from the chat? No? Så lydigt gick ner när moderatorn sa till. Jag älskar er. Kan vi inte alltid vara tillsammans på seminarier? Det tycker jag var jättebra. Fantastiskt. Därför det är ju så alltid med seminarier att man har så pressat tidsschema. Och man vill inte tappa några minuter därför man vet att det som talarna ska säga är så intressant och viktigt. Så därför var det så viktigt att vi kunde komma igång igen. And now, back to business. And I would like...
worried that we will have this meeting in Swedish. And I was like, what?
I didn't inform you. Your speech should be in Swedish. Oh, sorry, forgot that. No, it will be in English. And now we will focus upon a totally different perspective from the ones that we have heard of before the break. And we welcome Nesli Söser. Please come up, Nesli. She is a professor at VTT, Technical Research Center of Finland. And she is passionate about bringing food science and technology into novel products that we can eat. And currently, Nesli is leading a national, that is Finnish, and European projects focusing on protein extraction from plant-based materials and side streams, including also food design. And this we will hear more about now. So please, Nesli, the floor is yours.
Thank you. Thank you, Annika. Before I present, I have a question to the audience and to the online participants. How many of you are regular consumers of plant-based foods? Wow, I'm surprised. How many of you are regular consumers of plant-based dairy and meat alternatives? This is what I expected. Let's see if in the future you will change your mind. And now this doesn't work. Yes, now it works. Yeah, my talk will be indeed focusing on the role of technology on uptake of plant-based foods. Well, the first talks already mentioned that we have to make the food production sustainable, and when we look at the food system, the livestock production is the one that's very costly for us. It costs 27% of fresh water, 75% of agricultural land. globally 26% of total land, and 15% of greenhouse gas emissions. Yet, as the FAO director said, plants are the core basis for life. There are around 200,000 plant species that's edible for humans, but yet we consume only a tiny fraction of this, which is about 200. And if we look at the globally, there are 3 main crops: corn, rice, and wheat. But the opportunities are beyond these 3 crops. Also, the previous speakers has referred to the famous Eat Lancet, and I will do the same. And we know also by background scientific research that plant-based foods are more sustainable and can play a key role in reducing the environmental impact of current food production system. But they have to be optimized for taste, optimized for nutrition, and optimized for cost. We cannot just keep on eating beans or potatoes and carrots. When it comes to the functionality of animal versus plant proteins, they differ a lot. We have heard about the nutritional performance, but also from the technological perspective, animal and plant proteins have a major structural difference, which restricts the applicability of plant proteins in many food product formulations. For example, foaming is very essential when we are trying to integrate egg replacers in cakes. Colloidal stability is especially important when it comes to plant-based drinks. Gelation is very important when it comes to spoonable products such as yogurts. And then when it comes to development of a meat analog structure, then the fibrillation, the unique fibrillation that you get from the meat that you're eating is extremely challenging. But it's a very important parameter. When it comes to the plant-based ingredients, they typically come in 3 forms: flours, then concentrates, and isolates. And in this triangle, when you move towards more isolated protein fraction, obviously you start to increase the degree of purification, which means that you are losing substantially macro and micronutrients. Of course, then you increase the functionality, then it's much more easier for food scientists and technologists to handle, but then you increase the cost, then it's less affordable by the consumer. And then, obviously, when we are talking about isolates, then you are generating many side streams, then it also reduces the efficiency of the production. One important thing that I would like to highlight with the isolates versus concentrates or protein-enriched flours is that, obviously, oftentimes the isolation process includes wet extraction, which means that it requires lots of water and of course, for further downstream processing, much more energy than dry fractionation. Therefore, I will give you a brief overview of what could be a sustainable way of producing plant-based protein-rich ingredients. And the case that I will present you today is dry fractionation. As it's obvious from the name, this process does not include any wet processing, any water or solvent extraction steps. Okay, this is not moving. Yes. Brief introduction to dry fractionation. So basically, you can apply dry fractionation technology by using different grains, such as we have at VTT a patented technology around oat oat dry fractionation, different oil seeds, pulses, and also different agricultural side streams such as brands or oil press cakes. Then, if you have high lipid content, for example, more than 5% in the biomass, it starts to interfere and makes the dry fractionation challenging. Then you need to take it away. And this is the only step that you would need to think about. Okay, are you going to do solvent extraction or supercritical carbon dioxide extraction, which will keep the native properties of the proteins there? Sometimes the moisture adjustment might be also needed if the biomass or then the grains comes in quite high water level. Then you might do also some minor adjustments there. After these pre-processing steps, then it goes to disintegration, where we grind and mill, and comes the main part, which is the fractionation by using air classification. And in order to get the highest efficiency from air classification, you should have differences in the density and particle size of the components that you wish to separate. Oftentimes, we have been using this technology to separate the protein and starch fractions. So proteins goes to the fine fraction. They have much smaller particle size than compared to, for example, starch or dietary fiber. So the coarse fraction is typically a fraction that's enriched with starch and dietary fiber. The main advantages of dry fractionation, it's a very efficient, water lean, energy efficient separation technology. And as there is no water involved, then we assume that also it's also microbiologically safe. No chemicals are involved, then the proteins come mainly in native form, and then you can get several high-value ingredients. The downside is that if you want to get an isolate out of this process, I can say forget about it. It will never happen. Even 60% protein content is oftentimes very challenging to reach. So typically, if you take into account also the compromise between the protein content and yield, which dictates the price, then from this process, a viable ingredient has oftentimes 30 to 40% protein content. The only crop that we have been very lucky is actually the faba beans. Faba beans is amazing, and also pea. To separate with dry fractionation technology, you can very easily go to these high protein contents, like 60%. As I mentioned also earlier, although this is very efficient and water lean process, it doesn't mean that you can use the dry fractionation technology for any material that you have. You must have a particle size and density difference in the components. An example on comparing wet and dry fractionation and how it affects the functionality. So this example is from oat protein, and this is oat protein concentrate obtained by dry separation, and this is a commercial oat protein concentrate that has been obtained by wet extraction. As you can see, the solubility of the protein fractions are rather low with the wet extracted sample, which is validated with the differential scanning calorimeter thermogram. So when you get this high enthalpy peaks, endothermic peaks here, that means that the proteins are indeed in native form, whereas in the commercial sample, you get almost a flat curve. Now I will give some examples from the applications. The first application which I will focus will be dairy alternatives. We had actually a BBI project and then also an EIT food project which has ended a couple of years ago, where we looked at valorization of side streams, for example, rice bran and then rapeseed press cake. And actually this is with the most of the plant materials. There is, of course, the inferior or poor gel-forming ability, which is oftentimes related to the presence of phytic acid. And what we have done is that we have degraded to the phytic acid by using phytase enzyme. And here the reduction of phytic acid and its connection to protein functionality is extremely multidimensional. I will give a brief overview on that, but it's really a complex mechanism. So when we have reduced the phytic acid content, for example, in the rice bran, from 22% to 3%, we have seen an increase in the gel-forming capacity. We have also seen the similar approach in the rapeseed press cake, and gel firmness increased. And how we have done that? Typically, phytic acid and proteins, they form binary complexes. And phytic acid forms this binary complex in a wide range of pH. And it's negatively charged, and then proteins positively charged, and then they form the strong complexes which interferes with the gel forming. When we have done the phytase treatment and then at pH 8, which means that the proteins this time are negatively charged, but then what can also happen sometimes that when you have still the phytic acid there, just by increasing the pH without any phytase treatment, then this time they form ternary complexes, so three complexes. So protein, and then comes the ions there, and then like salts present in the system, and then also phytic acid, which again forms a very tight structure that disables the integration of proteins. So when we have done the phytase treatment at pH 8, then there was better interaction of the proteins with each other. Also, steric stabilization by using protein polysaccharide conjugates can improve the dispersion stability. This time the case is old protein isolate at acidic pH. So in the upper part, you would see that basically there is no stability if we just make a old protein isolate-based dispersion. It just sediments immediately. But what we have done is that we have added 0.5% of pectin and then made again dispersion, stored this 1 week at room temperature, and we again got almost exactly the same stability as 1 week ago. And here the mechanism is such that so these yellow particles there are protein bodies, and then pectin attaches from one side to the protein, and then it has this entangles. And then obviously when there is steric stabilization here, because then they start to be more in the stable form, so they are not aggregating with each other, so they are repulsing each other. Then the next example I will give is from the meat alternatives, or maybe a correct term will be meat analogs. And how we make the meat analogs, obviously you can also use traditional dry extrusion technology, but then you have to still rehydrate the product, and then you don't necessarily get really a replica of a meat-like texture. It's more like a sponge. Probably you are familiar with the soy grits or pea grits. With high moisture extrusion, it's ideologically similar to traditional extrusion processing, which we call dry extrusion processing, but it has been relatively less applied for design of food structures. It again includes a twin screw extruder, but then what is very critical is a long cooling die attached to it. Obviously, you also need quite high level of protein content there, like around 60–70% of protein content, so that you get the nice fibrillar structure. What happens during extrusion is that obviously proteins denaturate because it's high temperature, high pressure process. Then they start to, in the cooling die, make alignment and then cross-link with each other to forming the three-dimensional anisotropic network that resembles the meat-like texture and structure. Besides proteins, of course, there are other protein denaturation, other reactions occurring during extrusion processing. If you especially lower the protein content there, that means that you have other co-components, for example, starch, it gelatinizes. If you have fibers, dietary fibers, then it starts to also solubilize. And of course, you are creating in situ flavor formation next to texture. Some examples on how things can go wrong and how things can go right. I must say that there is a very narrow window when we are talking about high moisture extrusion processing when things go right. And here are some examples from rice protein isolate, gluten, pea protein concentrate, pea isolate, and faba concentrate. And these are on the top level are the optimized fibrillation and optimized structures. But then you can also get something like this from a pea protein isolate. That's nowadays, by the way, the most popular protein source in this alternative space. You can really get a very tight, almost like a cable type of structure, heavily cross-linked. So you need to know your ingredients, you need to know the functionality of the ingredients, you need to know how to fine-tune the extrusion processing, and so that you get really optimized structures in the end, optimized for texture, flavor, and also nutrition. Again, an example from the rapeseed protein concentrate. As I said, we had this project focusing on rapeseed press cake valorization. We have done dry fractionation to obtain the rapeseed protein concentrate, and we have extruded it with integrating cross-linking enzymes. And what we have found is that when we have treated the rapeseed protein concentrate with trans and protein glutaminase, including with a preheating step, we get really, really nice fibrillar, okay, wrong button, fibrillar structures. And this should be the button. And you can also see that the tensile strength was also optimized, was the highest in this trans-protein glutaminase preheated sample. So we want to work with concentrates. We don't want to work with isolates because of cost reasons, and then we want to also get other nutrients together with the proteins. So for that, what we have done is that this was a mechanistic study with pea protein concentrate. We have first lowered the pH just to mimic the fermentation conditions, and then by just chemically reducing the pH, and then shifted the pH to higher, actually neutral pH. So we were playing with the, so we were making the isoelectric point, getting it closer to the isoelectric point. And what we have seen is that with when we have made this pH shift, especially we get very good fibrillation at lower temperatures. That means that we would be also saving from the energy, but then also improve the protein digestibility. I don't have a protein digestibility data here, but that's what we assume. My last focus will be on hybrid foods. And with hybrid foods, what I mean here is obviously combining plant-based ingredients with animal ingredients, such as dairy ingredients and actual meat, which is produced by the animals. That can help us to close the gap between the plant space and then also the animal space. However, we can also consider hybrid foods where we combine plant-based ingredients with animal ingredients that are produced by microbes. An existing commercially successful example to this is the Impossible Burger, where they have developed a burger that's made by using pea protein, basically, and then they have added a little amount of biotechnically produced heme protein, and heme is the protein which gives the taste to red meat, and then also it makes it bleed. We have also, within the EIT community, had an access to a large consumer study done in UK, Denmark, and Spain. So the common focus of this selection of these countries those are the countries that the meat consumption, especially red meat consumption, is rather high. And consumers stated that they want healthier beef products where addition of plant protein was one of the most common suggestions. So although the previous speaker said this is a battle, I think there is still hope that we can win this battle. And then in this year's EIT food project, we have, with that in mind, we have developed hybrid extrudates where we have mixed pea protein isolate and pea protein concentrate with minced beef. This was just, a model and concept test we wanted to do, which contains 7% or 17% meat. So 7% fat containing minced beef is the lean version, and then 17% of fat containing minced beef is the normal, regular beef version. And we have had lots of challenges during extrusion because of high fat content. Those who are familiar with extrusion processing, you can expect that there was all sorts of leakage at the high addition levels from the extruder barrel. And then we had also challenges that the mechanical energy input during extrusion was also dissipating. That's something that you don't want to have. You want to put more energy so that the proteins start to interact with each other. But then when we have used pea protein concentrate, we knew that the texturized pea protein concentrate has better oil binding properties, so it did work quite well. And we got very distinct structures, really very fine, very thin fibrils, as opposed to you would get with actual plant-based meat analogs. And we got also very good textural response. But what was even more interesting, we have made a trained sensory panel. And we have asked the trained sensory panelists to evaluate the flavor, structure, and texture of the hybrids. And the panelists said that the hybrid extrudates with pea protein concentrate has a meat-like odor and umami taste, while extrudates made with pea protein isolate had a dominant pea-like taste and odor. And they have also stated that the fat content did not significantly affect the sensory properties, which means that even at low levels of animal fat can enhance the flavor and odor of plant protein extrudates. With that in mind, as VTT is one of the research organizations strong in biotechnology and cellular agriculture, we said, okay, meat lipids is really critical here when it comes to taste and the overall eating experience. Can we produce meat lipids in a more sustainable and healthy way by using cell factories? And I will show some very initial results from that. I will wrap soon. And we have also, we can also combine the plant and cell hybrids so that we come over the flavor and texture challenges. When it comes to lipids that are important in food applications, they are mainly triacylglycerols, and they have 3 fatty acid residues, and as some of you know very well, that's the most caloric dense nutrient. When it comes to cells, there are certain microbes that can produce these lipids in an efficient way. They are called oleaginous yeasts that can produce more than 50% of the total dry cell mass is lipids. As you can see with this nice orange reddish color, that's actually Rhodotorula strain there. You can also get, together with the lipid, color component. That's very important when it comes to meat. And this color changes with cooking to more brown shades. You can optimize the lipid yield and composition, meaning that you don't need to have very saturated lipids. You can also optimize the lipid production in a way that you just get the right amount to give the flavor kick by playing with the growth conditions. And here you can see 5 different VTT strains where we have only adjusted the growth conditions, and we end up getting quite high, good amounts of stearic and palmitic acid, which we know from the literature, but based on our studies, those are the fatty acid compounds. That's quite important when it comes to giving the beef flavor to this beef flavor, actually. And then the myristic acid, that's the C14, is also has been expressed, of course, much less levels, but that's also quite important when it comes to the melting properties. So as a take-home message, food processing technologies can help to design healthy, appealing, and sustainable plant-based foods alternative to animal counterparts. Bioprocessing can be combined with, for example, high moisture extrusion, but it can also be utilized combination with enzymatic treatment to degrade the anti-nutritional factors. That's also one of the major challenges when it comes to plant-based ingredients. And I believe there is really good potential to make the general consumers also make this dietary shift smoothly by using more this hybrid foods, meaning combining plant-based with animal ingredients, but also having this low inclusion, high performance ingredients in the case of Impossible Burger. So thanks a lot, and I would be ready to give some answers to your questions. But before I do, I want to have just attention to our coming free seminar, which will be online and also on site. So we will be live streaming, like today. It will be on December 1st, and of course, for those who are online, probably you will not have a chance to click on these links, but you can email me, and I can for sure send you the link to the program, and then the registration is still by November 24th. We will be giving, we are just ending a very big national project funded by Business Finland, and then also EIT Food Project, and we will be sharing the results of those 2 projects in the event. But now, I'm ready to take the questions.
Thank you so much, Nestle. Unfortunately, there is hardly no time left for questions, but I would like to put one to you, and that is, there are many discussions going on when it comes to food, and another discussion, not really perhaps connected to what we are bringing up today, but another discussion is the should food be very natural, or can it be processed? And we quite often talk about ultra-processed food. And I think that what you have showed us here must be defined as ultra-processed food.
No, it shouldn't be defined as ultra-processed food.
But I think, could you just say something about this? Because we had an interesting discussion on this.
Yeah. I was waiting for this moment.
Yes.
So, I think when it comes to processing, ultra-processing, mild processing, and so on, we should be looking at it from the ingredient level, not so much from the food level. I mean, I have given a talk focusing only on this processing topic, and I give there the same example which I will give now, again based on extrusion processing. By using extrusion processing, you can create a very unhealthy product with lots of sugar and lots of starch, no fiber. Those are basically similar to the, I don't know if you have here Cheetos or Cheerios type of snacks, salty snacks. You can use the same processing technology to produce a whole grain oat snack. Or you can use the same technology to produce a very high fiber cereal product that you can consume with your yogurt or with your breakfast cereal. So it's not really the processing. You can, in your own home kitchens, just by using the home appliances, which is the minimal processing, create a very unhealthy food product with lots of carbohydrates, sugar, and fat. So what I'm trying to say is that we should be judging the foods as good, bad, and evil based on their nutritional composition, not how they are processed. If we want to focus on the processing side, I think it should be more in the ingredient part when we are refining. And oftentimes, that's not also an easy debate. Sometimes refining makes the ingredient more healthy.
Thank you for this explanation, Nestle. We have a question from the chat?
No, it's from me.
Oh, it has to be a short one, Ann-Sophie.
But I was very interested in that you were using phytase enzymes to degrade phytate, which is a
anti-nutritional. Yeah.
Now the mic went off.
Phytate is a major inhibitor of zinc and iron absorption in such products. So it's possible in rice to make protein.
Now you lost the mic again. You need to press it the whole time.
Okay. To make a protein without phytate, because it's normally accumulating in the protein fraction.
Yes, it does. Yeah. So actually, all the anti-nutritional factors, they go together with the protein. So when we do the concentration, it goes. That's actually the advantage of wet extraction. Typically, you don't get the anti-nutrients during the. I mean, you get rid of them during the wet extraction. Yes, but with phytase treatment, we were able to reduce it to 3%, not totally, but from 22 to 3%, which was an incremental.
So it's a possible solution to what is.
And that's something that they use in feed industry. Yeah. They are mixing the feed before giving it to animals with phytase to reduce the feed.
I'm sorry, but I have to interrupt you because we need to move on. Once again, thank you so very much, Nestle. And you can find Nestle on the internet at VTT in Finland if you want to continue or put questions. Now. We have almost got into our next presentation already, because now we are inviting Cecilia Meyer-Labba, who will be with us on the web. Hi there.
Yes, hi.
And Cecilia has recently defended her thesis, Nutritional Limitation with a Green Protein Shift on Iron, which is what the question from Ann-Sophie was close to touch upon. And that was at the Division of Food Science at Chalmers University of Technology. Please, Cecilia, the floor is yours.
Thank you so much, and thank you for a very interesting previous talks, yes, we got into some of the topics that I will talk about, especially phytate. And my talk is on nutritional limitations with meat analogs currently on the Swedish market. And it's from a publication that we just recently got published in Nutrients. So as we've also talked about today or heard today, is that meat substitutes is a very rapidly growing market. During the past 10 years, we've seen a very rapid growth in the sales of meat substitutes, and it's projected to continue. And meat alternatives, if I'm sure everyone already knows, but if someone doesn't, those are products typically striving to imitate qualities of specific types of meat, and such as sensory properties or appearance. So we have typically sausages or burgers, schnitzels, nuggets, and minced meat is also very common. And as we heard from Nestle, meat substitutes are commonly based on protein extract, plant protein extracts. We have a smaller group within this segment that is based on fermented, typically legumes, or consists of mycoprotein, which is a filamentous fungi. And this was very clearly demonstrated or illustrated by Nestle, so I will not talk so much about this. How it's produced. First, it's extracted. The protein is extracted by either wet or dry, as Nestle talked about. This upper left photo is from a wet extraction, and then it's texturized. The extract is texturized to get a more meat-like taste or texture. And typically these past years, it's been a very large focus on sensory properties, but not so much on what happens with the nutritional composition of the raw material. This is just a picture of what we did in our previous study. We collected a sample of each meat substitutes that was available from two common supermarkets in Gothenburg city, which gave a sample size of 44 different products. And extracted soy protein was the predominant source of protein, along with pea protein. We also analyzed a group of products that was based on this mycoprotein and tempeh. So we analyzed the nutritional composition and also estimated the bioavailability of iron and zinc in the products. We found very large variations in the composition of the meat substitutes. Interestingly, products that had extracted and extruded cereal protein, gluten protein, was the most common. They had a low content of methionine, and they hence cannot be regarded as complementary to legume protein. Otherwise, cereals are often suggested as suitable complement to legumes, since they contain normally a high level of methionine. Extraction and extrusion affect the amino acid composition. It is dependent on the methods used and the conditions used, so it has to be further taken into account. Many of the products had a high content of dietary fiber. The contribution from one portion of meat substitute to the recommended daily intake of dietary fiber, it varied from 10 to 14% from the fish fingers from wheat protein, which had the lowest content, and up to 27 to 38% of the recommended daily intake from the tempeh burger, which had the highest content. This is not so shocking, since the tempeh is a fermented product based on whole legumes. So of course it will have a lot more dietary fiber. There were large variations in the fat content, from 2 grams per 100 grams of protein of a product up to 22 grams of fat per 100 grams of product. Many of the products had a very high salt content, which has been highlighted previously. For example, a portion of a product, pea schnitzel, it would contribute to almost 60% of the maximum daily intake of salt. We did not find any clear correlations between product type and fat composition. Therefore, we analyzed the composition of fat based on the added fat. And as expected, the saturated fatty acids were, of course, highest among products that were added with coconut shea or palm oil. Essential fatty acids were highest among products that were added with sunflower oil due to the presence of linoleic acid, but it did not contain any omega-3 omega acids, as was expected. So the fat composition and also the salt content are results of the formulation rather than the raw material. So these two aspects can very easily be improved by the producers. A bit more tricky to improve is the bioavailability. And we estimated the bioavailability by analyzing the contents of phytate and putting that in relation to iron and zinc. And why are we interested in phytate? So as we heard, phytate can contribute to properties in the food matrix, but it's not so, it will have a negative effect when it is consumed. So it's an anti-nutrient with up to 6 phosphate groups, which are negatively charged under physiological conditions. And these phosphate groups can chelate cations, such as iron and zinc. And such a complex is insoluble under physiological conditions. So that means that a mineral bound to phytate will just pass through our digestive system without any absorption. And the inhibiting effect of phytate is dose-dependent and will negatively affect non-heme iron and zinc absorption at very low levels. So we use the phytate to iron and zinc molar ratios since it is used to estimate the inhibitory effect of a phytate by the World Health Organization, the United Nations Food and Agriculture Organization, and also by EFSA. And they state that phytate is the main inhibitor of non-heme iron absorption and zinc. So I have used the thresholds adopted by these 3 organizations to estimate this bioavailability. Yes, 1 mole of phytate can bind 6 moles of iron. And this is the variation of phytate to iron molar ratio in meat substitutes that were analyzed. That had an iron content about 2.1 milligrams per 100 gram of product. And we chose that because that's the threshold for making a nutrition claim on iron. But neither of the products had a molar ratio below 1, which was the level where phytate starts to greatly inhibit the non-heme iron absorption without any enhancers. And 6 of these products had a nutrition claim on iron. But apart from containing a minimum amount of the specific nutrient, there's also a condition that says that the nutrient for which the claim is made is in a form that is available to be used by the body. It has to be fulfilled for a permitted nutrition claim, as stated by the EU regulations on nutrition claims. Hence, nutrition claims on these products can be argued as not permitted and also misleading for the consumers. I did a small, sorry, this was in Swedish, but I did just a small calculation on how high the iron content would have to be for the molar ratio of iron or phytate to iron to be reach 1. And as you see, it's very, very high levels of iron. So therefore, fortification is unrealistic. And rather, we need new processing methods. Examples of methods to degrade phytate is fermentation, hydrothermal treatment, enzymatic treatment. We can also use plant breeding. And as Nestle mentioned, these very highly purified protein extracts they also have phytate removed. But then it's a question about the functionality of that kind of extract. To further illustrate the negative effect of phytate, I wanted to show you this slide here. It's from a clinical trial that we did on non-heme iron absorption. And we compared a meal with texturized, extracted and extruded fava bean protein in a single meal study. We compared that to cod protein and beef protein meals. And we saw that there was a significantly lower absorption of non-heme iron from the fava bean protein meal. And the contribution of the daily need of iron was only 7% from the fava bean meal and 28% from the beef meal. But the fava bean meal had the highest total content of iron. That further illustrates the importance of looking at bioavailability rather than the total iron content in these kind of products, these plant-based products. I also did scenario calculations. I will skip through maybe how I did it and just go to the calculations. But what happens if we exchange the total daily meat intake that is currently according to Riksmaten among Swedish women of fertile ages? It's 88 grams per day. If we so according to my calculations, a total exchange of the current meat intake into these 3 meat substitutes that I analyzed in this recent study, it would result in a very large decrease in the absorbed iron compared with what was expected from the meat fraction. And the largest decrease was found from protein extract products, as they contain a very high content of phytate. Mycoprotein, filamentous fungi, it doesn't contain any phytate, but they don't contain any iron at all. So therefore, the decrease was also very high. The smallest decrease in absorbed iron was calculated for tempeh due to the low phytate content and high estimated bioavailability. So at the same time, women of fertile ages belong to a risk group at developing iron deficiency. According to the most recent National Dietary Survey and blood sampling performed by the Swedish Food Agency, as many as every 3rd Swedish teenage girl has signs of iron deficiency. And it's estimated that every 4th Swedish women of fertile ages have iron deficiency. And these are the groups with the lowest meat intake and a higher intake of meat substitutes. So it's very important to improve this kind of products because it's aimed at a very vulnerable group. We often hear that we have to reduce our meat intake, but the question is who and what groups are receptive to those messages? These are numbers from 2010, and already then Swedish women had an intake of red and processed meat that was below the recommended maximum level set by the Swedish Food Agency. And among Swedish young women, which is the most vulnerable group, almost half of the population are completely or partially avoiding meat. I did a calculation to adjust the recommended daily intake for bioavailability. So now it's calculated at 15% by the Nordic nutrition recommendations, and that's a high bioavailability of iron, and it reflects a diet containing meat and animal products. But we see from a plant-based diet that its bioavailability of iron is rather low. It's maybe between 5 or to 12%. And if we then look at the adjusted intake that we would need to have to absorb as much iron as we need, we see that it's not reasonable. It's very high. So again, I think that processing is what we need to rather have better products than increase the iron intake by fortification or eating a very, very high amount of food. So the conclusions that we drew from this study was that there is a high content of phytate and a low estimated bioavailability of iron and zinc in meat substitutes that are currently on the Swedish market. Exception were the mycoprotein and tempeh products. And that the nutritional consequences of plant protein extraction and extrusion has not received enough emphasis. And that we need to have a development of nutritiously adequate meat substitutes to avoid negative effects following substitution of meat. And also lastly, that the nutrition claims on iron appear to be not in line with the European regulation, but it has so far not been legally tested. Yes, so that was my quick presentation.
Thank you very much, Cecilia. Very interesting thesis, I think, and very interesting research and results. Do we have a question for Cecilia? Yes? Please use the microphone. Yes?
Yes. Hi, I'm Karin from Lantmännen. Thank you, Cecilia, for a good presentation. I'm just curious to know, on the products on the market that you studied, did you see any nutrition claim on iron on those?
Yes. We saw, I had it on one of the slides. Let's see. We saw there were quite many, 15% of the products had nutrition claims on iron. Maybe I can share this slide again. Yes. So, as I said, 59% of the products had iron contents that were above 2.1 milligram per 100 grams. So they could have made a nutrition claim on iron if it wasn't the problem with bioavailability. But six had. One of the products that had a claim actually had an iron content that was below 2.1. But of course, it's difference in batches. So, and I think this is a problem because many people that eat plant-based, they know that iron is an issue, and they tend to choose or look at products that they believe that they can absorb iron from or meet their iron needs. So I think this is misleading.
Thank you. I absolutely agree. Thanks.
Thank you so much. Do we have a question in the chat? Ann-Sofie?
Yes, there was one question, and that was from Rickard Lundberg. And he asks, did you assess iron status when looking at iron absorption of non-heme iron?
Yes, We did. And we also adjusted for, we had a reference dose. So first of all, we didn't include anyone that were anemic or had iron deficiency. And then we used a reference dose that we adjusted the individual differences towards to avoid those kind of differences due to iron status.
I also think it's important to say that it was single meal studies, so we did not consider that the single meal would affect the iron status directly. It takes more time.
Yes, definitely.
Thank you. I really hope that these results, that you can get industry to look upon them and to change recipes and to develop production further. We have come, thank you so much, Cecilia. I think we give... in no way I could summarize all the very interesting things that we have discussed here today, but some concluding remarks I want to make. And the first one is, of course, that change is needed. There is no way we can get away from this. We need to change our eating habits and the food we eat. We need to eat less, especially in this part of the world. Just eat less would be a great step forward. And we need to eat less of some products, but it's not that easy that everyone needs to eat less of the same products. It's quite a difference. And as Edith talked about already in the first presentation, we have no lack of protein in our part of the world, but in large part of the world today, still there is a problem with too little access to protein. So we need to understand and remember this. I think Crystal showed us very interesting things about what is happening with land use. And she also said something that I want us to remember. When we look at the impact from different types of production, we must not only look back to what agriculture has been in the past, we need to look forward and see the enormous possibilities to develop agriculture for future with much less negative impact on environment and climate and so on. And she also showed us that ecological farming is a very small part of agriculture, but it is also a sort of an innovative system for a much larger part of agriculture, where the machinery that we saw was developed originally for eco-farming, for biological farming, but is now being used by also conventional farming. And I think that is interesting to remember. I thought it was really interesting to hear about political consumerism and to understand that it's both good and bad. I mean, it has been a driver in the way that it has increased our consciousness in society about these issues. But it can, of course, be a problem when it creates conflicts and rather make people more stubborn and saying, no, I will never change. So we need to find ways out of that and into a more constructive discussion. And I also think we haven't really discussed who is responsible for what, but we have, I think, understood that there are so many different things that need to be changed. We have talked about the system level, and in this system level, there are so many different actors that all must come together and do their part of the work. Politicians who, I think, pay much too little attention to these problems when it comes to healthy diets. Industry, of course, who need to develop the products that we need. We ourselves as consumers, although it is very difficult as a single consumer to make all the right choices. It's just, we can do some of them, but we can't do all. And all of you involved in producing food in public sector, for example, in schools, hospitals, and so on, there is a huge task for you to deal with this. And all of us need to come together. And we have also learned that food consumption comes in a context. It comes with a culture, a tradition, and this is, I guess, why we need to develop products that are very similar to those animal-based products. I mean, in India, they have 500 million vegetarians, and they don't need to have food looking like beef, because they have another tradition, another culture, another history. But for us, it will be difficult if we can't see anything that we recognize about the new food products. And finally, Cecilia told us that when we do this, we need to be aware of the nutritional content of these new products. And it is really important what she told us about how many problems there are today with the products, with too much salt and too wrong fatty acids and anti-nutritional content. So the single conclusion that we can make is that there's a lot of work to do, and that we all need to go home and just start doing it. Thank you so much for staying with us all the time.